So problem number 4, very, very easy. You just have to know how to use the little formula they gave you. So they gave us this formula that looks a little bit strange. It says find the first 5 terms. So I'm going to find the first term, second term, third term, fourth term, fifth term. This is my notation. That's what this notation means. And they told me that the first term is 3. Okay? So now I'm going to find the second term. Now look at your formula. If I want this to be a sub 2, that's what I'm trying to find is a sub 2. Aren't I going to let n be 1? If I let n be 1, would this say a sub 2? And if I let n be 1, then this is going to say 2a sub 1 minus 5. I need this to say a sub 2. I need that to be a 2. So if n plus 1 is 2, then n is 1, so let n be 1. And then my equation says a sub 2 is 2a sub 1 minus 5. But what's a sub 1? 3. So this is 2 times 3 minus 5. So a sub 2, the second term, is 1. Okay, now what am I going to do here? I'm going to let n be 2. So that my equation says a sub 3 equals 2a sub 2 minus 5. But I know a sub 2 is 1. So 2 times 1 minus 5, negative 3. See what's happening? Where's building? So a sub 4. What's a sub 4 going to be? A sub 4 is going to equal what? 2a sub 3 minus 5. But a sub 3 is negative 3. So is that negative 11? Times 1, a sub 2 is 1, 2 times 1 minus 5 is negative 3. Now what's a sub 5 going to be? You want to find a sub 5, so it's going to be 2a sub 4 minus 5, which is 2 times negative 11, negative 27. Negative 22 minus 5, negative 27. So there are the first 5 terms. That sequence, by the way, is not arithmetic or geometric. There's a pattern maybe there that you see, but certainly our formula is not going to help us with that one. All right, let's see if you can do the next one. Same exact idea, different formula. We're finding the first 5 terms, but this time they gave me the first 2. They gave me that head start. The first 2 are 3 and 4. Okay, now if we're going to find a sub 3, that's the next thing. That's the first thing we have to do. We're going to find a sub 3. What is n going to have to be? If this is going to be a sub 3, n is going to have to be 1. So this is going to say a sub 2 times a sub 1. So a sub 3 is going to be a sub 2 times a sub 1, which is 4 times 3, or 12. Look guys, some of you look like deer in headlights. So first of all, you need to engage. And second of all, this is a number, this is 1 more than a number, and this is 2 more than that first number. These are consecutive integers. So if this is a sub 4, this would be a sub 5, and this would be a sub 6. So you're just multiplying 2 together to get the next one, right? So 2 times 4 gives me the third number, which is 12. What's the fourth number gonna be? The third one times the second one. Okay, so one more time. I am finding a sub 4. N plus 2 is 4. So what does that mean n plus 1 has to be? If n plus 2 is 4, then isn't n 2? 2 plus 2 is 4? So what's this? A sub 3, and what's this? Yeah. So I'm multiplying a sub 3 times a sub 2, which is going to be 12 times 4, 48. And then what about a sub 5? Figure that one out. What's a sub 5? Probably need a calculator. At least I need a calculator. Who's got it?
576.
576. Very good. Because it's a sub 4 times a sub 3. So it's 48 times 12. 576. Yep. That's exactly right. All right, you and your partner do this last one. Got a different formula, different pattern, but same idea. What's the first term we're finding? A sub 2. Which means, what does n have to be? If we're finding a sub 2, then n has to be 2. And if n is 2, then this says 3a sub 1 plus 2. What's a sub 1? 4 plus 2 would make 14. Now, I want to find a sub 3. That's my next job, a sub 3. So what's n? 3. So this is going to be 3 times a sub 2 plus 2. So that's 44. 3 times 14 is 42, 44. All right, find the other 2. Need a calculator. Some of these are kind of big. What'd you get for your fourth term? 134, because it's 3 times the third term plus 2, so it's 134. And then, what'd you get for the last one? 404. Perfect. All right, number 5. We want to find, or consider the sequence, figure out what kind it is, find the 8th term and your explicit rule. Okay, this is easy. I think we can do this. What kind of sequence is that? What's happening? The arithmetic, which means it has a common difference, and And what would its common difference be? How are we getting from term to term? Adding -4, so subtracting 4, adding -4. So my difference is -4. I need the 8th term. Now, luckily, I do not have to go through a process like this, because to get the 8th term over here, I would have to just keep going, 6, 7, 8. Here I can jump straight to it, because I have a formula. What is my formula for an arithmetic sequence? The 8th term will be what? The 8th term is the first term, which is 3, plus the common difference, which is -4, times n minus 1, and what's my n in my problem? 8, so 7. So it looks like -25 is the 8th term of the sequence. Could I find the 80th term of the sequence? Yeah. The explicit rule or formula is simply, go back to this one, if we want the in general, the explicit rule, we're going to start with our first term, we're going to add our common difference times n minus 1. That's the explicit rule. This will find whatever term you want. If you want the 8th term, you put an 8 in there. If you want the 90th term, you put a 90 in there. Normally we do the distributive property and clean this up a little bit. So our explicit rule is 7 minus 4n or -4n plus 7. It doesn't matter which order you write those. That's the explicit rule. So the explicit rule comes straight from our formula, and we just plug in the specifics for this problem, which is the first term and the common difference. Then this formula will give me anything I want. The 100th term, the 1000th term, is called the explicit rule. The explicit formula takes you straight to the term you want. Unlike these are not explicit rules, these are recursive. All right, let's look at the next one. How about this one? What's happening in problem B?
Geometric.
It's geometric. Why is it geometric?
Times 2.
We're multiplying by 2. So my common ratio is 2. And since I'm geometric, I don't use that formula. I use my geometric formula. So if I want the 8th term again, randomly, the 8th term, according to the formula, how will I find the 8th term? I'll take the first term times the common ratio to what power? 7. Yep. And I'll get 384. Now, what is this is the 8th term. This is the formula for the 8th term. What does the formula for the nth term look like? Well, this is even easier. It's just 3 times 2 to the n minus first. Yeah, that's it. That is your explicit rule. Never multiply these two together. These two do not multiply because this one has an exponent. So this is your explicit rule. Look, if I wanted the 100th term, could I find it? Yep. 3 times 2 to the 99, it'll be huge, but that would be the 100th term. Any term I want. The explicit rule gives me any term I want. Okay, how about the next one? What's going on in the next one? Problem C. Geometric with a common ratio of -3. Ratios can be negative, not a problem. So the 8th term be the first term times the common ratio to the 7th. Right, using this formula up here. So type that in carefully. And what did you come up with? 13,122. So what will this is the formula for the 8th term. What is my formula for any term in general? -6 times -3 to the n minus first. That's called the explicit rule. That is the formula for this problem. This is the general formula for every geometric sequence. This one is specific to this particular problem. Do not ever combine these two numbers. They stay separated. All right, D, what's happening there? This one's arithmetic, so it has a common difference. And what is the common difference? -1/2. Those are all decimals, so I'll say -0.5. It doesn't matter. You can say whatever you want. So arithmetic, I erased the formula, it was right up there. The arithmetic formula says that the 8th term is going to be found by doing what? What's the arithmetic formula say? Take the first term, which is 10, plus the common difference times, in this case, 7, because I want the 8th term, and the formula says n minus 1. So it looks like that's going to be what? Say 6.5. All right, so what is it in general? The nth term for this sequence, the nth term will be 10 plus -0.5 times n minus 1. This sequence has 10 as a first term, -0.5 as a common difference. So we'll distribute this one. You can clean up. Did you get 10.5 minus 25n as your explicit formula? All right, you and your partner do the last one. So you're going to find the 8th term, and you're going to find the formula for the nth term for this sequence. By the way, the first thing you have to do is figure out what's going on. Is this guy arithmetic or geometric?
Geometric.
And if you have figured out it's geometric, then you ought to be able to figure out what we're multiplying by. 1/8. So then, your 8th term is going to be small, so don't be alarmed if you get a decimal or a small fraction. It's 8 times 1/8 to the 7th, which is 3.815 times 10 to the -6. Is that what you got? Now, again, kids, that needs to make sense to you. You keep multiplying by an 8th. What is happening to your number if you multiply by an 8th? It gets really smaller. Really smaller. All right, the nth term then will be 1/8 to the n minus first, that's all there is to it. And I know you are tempted, do not. This is the answer, that is the formula for the nth term of this particular sequence. Alright, I need you to really put those thinking caps on, guys. I know it's Friday, with all your tests and everything, it's been a long week, I get it, but we really need to think about these next problems. 6A says, I have an arithmetic sequence where the fourth term is -8 and the seventh term is 4. Now, I am a very visual person, so I like to kind of draw pictures, I kind of visualize what's happening. So this is arithmetic, which means what am I doing? To get from here to here to here to here, I am adding. And all I know is that the fourth term is this, and the eighth term, or seventh term, seventh term is that. Okay? It's arithmetic, that's key, it's arithmetic. So, how far is this distance right here? 12. So to make it 12 units, I added something once, twice, 3 times. Does that make sense to you? If it's arithmetic, I'm adding the same thing. I added something 3 times to give me a total of 12. What did I add? 4. So if I added 4, then this number would be -4, this number would be 0, and that number would be 4. What about the other direction? This would be -12, -16, -20. The question says, find the first term down. Got it. The first term is -20. Let's look at the next one. This one's geometric. The second term is 3. Third, fourth, fifth, sixth, seventh, eighth term is 192. 2, 3, 4, 5, 6, 7, 8 term. Yeah. Now, this time I'm not adding, this time I'm multiplying, right? So I'm multiplying and multiplying and multiplying. How many times am I multiplying? 1, 2, 3, 4, 5, 6 times. To get from here to here, I'm going to multiply 6 times by the same number. And I have to get from 3 to 192. So what is the total of the multiplication? Like here, the total was adding 12. What's the total that I'm multiplying by to get from 3 to 192? Yeah, which is 64. So, think about this now. I am going to multiply by something 6 times and end up multiplying by 64. So that's the 6 through the 64, which is 2. So we're multiplying by 2, which means this way, this is the term I want right here. What's this going to be? 1 1/2, 3 halves. We divide it by 2 to go backwards. So something to the 6th power has to be the equivalent of 64. And that's how we got 2. 2 to the 6th is 64. These are like puzzles, you can figure them out. Alright, see if you can figure out this next one. It is arithmetic. we've got an arithmetic sequence. We know the 5th term and the 9th term. And we want the 1st term. It's kind of a shortcut for this one, I think. Like these and then, but let's look it over and see what you think. See if you can come up with the 1st term, and we'll talk about how you did it. You think it's 7? Is that what someone said, 7?
Yeah.
Okay, I don't know. I don't have the answer. I don't know yet. Anybody have a different idea? Did you that too?
I got 7.
Everybody got 7. All right. Somebody who got 7, tell me what went through your brain.
The difference between a 5, or to get from a -5 to a -17 is -12, and it like jumped, or you add a negative 4 times, so then you know that the common difference is -3.
Yep. And since it was negative going that way, you added to go this way. So +3, +3, +3, +3. Did anybody have a different thought? Now this won't work all the time, but it would in this problem. How many blanks or skips, how many blanks are there between your -5 and your -17? 3 blanks in there, right? I mean 3 missing numbers. How many missing numbers between the -5 and the one you want? No, how many missing numbers between these two? 3. So if to skip over 3 this way was -12, wouldn't skipping over 3 this way be +12? And -5 + 12 is 7. Now that only worked because we were balanced on both sides, but that's another way you could have thought about it. Last one, now we're geometric. 3rd term is -75, 4th, 5th, 6th term is -93.75. Now kids, we're geometric, so we're multiplying. 9375 divided by 75 is 125. So to get from here to here, we have to multiply by 125. To get from here to here. This means 1, 2, 3 steps. Multiply by something, multiply by something, multiply by something. So what would I multiply 3 times to get 125? 5. So if I am multiplying by 5 to go that way, I'm dividing this way. So -15, -3, is that what you got? It's like a puzzle, you have to think about it. All right, 9-4 homework, due Tuesday. All right, let's look at 9-5. I don't know if we'll get through this entire, I'm not talking about today, I'm just talking about in general, because our days are numbered. We gotta do a little exam review. Has anybody ever seen this symbol right here? Have you ever seen that anywhere? Abe?
See it in physics.
See it in physics. What's it mean in physics?
Summation or something?
Exactly. This guy right here is he's called a capital letter sigma. So if you've been like on a fraternity row, you've seen sigmas. But the capital Greek letter sigma always means sum. It's a summation. You're adding them up. Used symbols used in calculus all the time and in physics. All the time. Now, statistics, all the time. Now, what does this mean? What am I adding? Well, take whatever number is down here. In this case, it's a 1. It doesn't have to be a 1. It's often a 1 because it's the starting point, and you plug it in. So if I plug 1 into this expression, I get 5. That's the first number I'm adding, 5. Then I'm going to plug in 2. So I started with 1. I'm going to plug in 2, and I get 7. And then I'm going to plug in 3, and I get 9. And then I'm going to plug in 4, and I get 11, and I'm going to stop because there's a 4 right there. This is where I start. This is where I end. And then I add all those up, and that's the answer to the question. So what is that? 32. That's it. It's easy. All right, let's look at the next one. Okay, so what am I adding here? Well, remember, this tells you where to start. It's usually a 1, but it doesn't have to be. It's not. That's fine. Start by putting in 2. So you put in 2, the first number you're adding is 1. And then you put in a 3, and a 4, and a 5, and a 6. And there are the numbers that you're adding. The answer to the question is the sum, like Abe said, summation. I got 15, did you? Okay. All right, last one. Would you do the last one on your own? Same exact thing. Adding up some numbers. Easy? All right, well, here we go, one more. Whoa, 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 this is striking fear into your heart, as it should, because why? I'm not counting up to 100, he says. Now, here, I want to count out some of them. I want to look at some of them. So, if I were going to write all this out, and we are not, but we have to write out a few, because we have to figure out what's going on. So if I plug in a 1, I get -1. If I plug in a 2, I get +1. If I plug in 3, I get 3, and I'll do one more. If I plug in 4, I get 5. Now, I am not anywhere close to being done. But, do you see a pattern here? So this series right here, when they have pluses, we call it a series, not a sequence. This series right here is arithmetic. Would you agree with me? And as with all things arithmetic, we can formula it. So, I'm going to give you 3 new formulas. Again, you don't have to memorize them, but you have to know which one goes with which. So, here we go. Your arithmetic series, these are your sum formulas, is this. Okay, that's my arithmetic. Can you see that? Let me write it down here. So when you want to add an arithmetic set of numbers, that's the formula you use. We'll be doing that in a minute, because this is arithmetic. I'm going to go ahead and give you the other ones. This is your geometric formula. And you will never be confused by that, because see these R's right here? What do you think those R's stand for? Ratio. And if you're ratio, you are geometric. So no confusion, that one's geometric. then, this is crazy, and you're gonna think, what? But I want you to write down anyway. You can add up an infinite geometric set of numbers. So in other words, if we kept this series going forever, and it was geometric, this one we can't because it's arithmetic, but if we had one that was geometric, sometimes we can add them up. So we have these three formulas at our disposal. Notice, this one does not have an n, because it's infinite. N stands for how many terms there are. You don't have that down here because it's infinite. All right, let's talk about getting an answer to problem D. Okay, you figured out, we wrote out a few terms so that you could figure out if it was arithmetic or geometric. You figured out it's arithmetic, so this is our formula. Now, how many terms, if we wrote them all out, how many terms would there be? How many am I adding up? Well, I'm starting with 1 and going to 100. So how many numbers is that? 100. So that's 100 numbers. So 100 over 2. Now, what does a sub 1 stand for? The first one, first term, and the first term is -1. What does this stand for? For us, it would be a sub 100. What is that? Yeah, plug in 100. It's the last one. But we can find the last one really easily because isn't this going to be the last one? So if we kept going, eventually we'd be plugging in 100 and we would get 197. So the last number in our list is 197. You just type it in. And I got 9,800, 9,800. Is that what you got or not? Anybody match that?
Yeah.
Good, thank you. All right, letter E. All right, it's definitely geometric. Guys, if you plug a 1 in, right here, if you plug a 1 in, it makes that exponent 0. And anything to the zeroth is 1. So what is the first term that I would be adding? -2. Now what happens when you plug in a 2 here? Then you get -6. Let's do one more. Let's put in a 3 here. -18. What's going on? Somebody said geometric, and whoever said that was right. And the ratio is -3? Or 3, just 3. The ratio is 3. So we're going to use now this formula. And we're going to add up how many terms. If we wrote them all out, we started with 1, we're ending with 15. How many terms is that? 15. 1, 2, 3, 4, 5, all the way up to 15. So there are 15 terms that we're adding up. The first one we calculated to be -2. The ratio we figured out was 3. The exponent is going to be 15. These match. And 1 minus the ratio. These can be a little wacky to type in. So I always just go ahead and do my denominator. My denominator is going to be -2. hope you expected a big answer, because you're gonna get one. What'd you get? Negative 14348,906. So negative 14 million. If you didn't get that, be real careful. You have to hit equals. You have to type in your numerator and hit equals, and then divide it by 2, so that it divides the whole numerator. So make sure you're hitting equals before divided by. All right, one more of these. Oh, wait. What's different about this one? It's infinite. How do we know it's infinite? There's no thing on the top, which, remember, the top gives you your stop. Well, if there's nothing up there, that means it doesn't stop. So let's write out a few of them. What do you get if you put a 1 right here? What do you get if you put a 1 right there? 2. What do you get if you put a 2 right there? 6 over 9, which is 2/3. What do you get if you put a 3 right there? 6 over 27, which reduces to 2/9. Now, can you tell what's happening to those terms? Can you tell what you're multiplying by? A third? So the ratio is a third. Now, my formula, this is an easy one to use. It says take the first term, which you figured out to be 2, and divide it by 1 minus the ratio. So we're gonna have, oh good, thank you. Yay! Now I can do a fire drill. Yay! Okay, so I have 2 over 1 minus 2/3, or 2 over 1 minus 1/3, which is 2/3. So you can do this on your calculator, you're gonna have a calculator, or you can remember that's 2 times 3 halves. So it looks like the sum is just going to be 3. Now, we need to talk about this for a second, because this problem was doable only because, when you think about what you're doing, guys, this is going on forever. This is never stopping, and yet you're adding it up. That's only possible because what's happening to these terms? They're getting smaller. And if I keep going far enough, they're eventually going to get so small, they're going to be like 0. So an infinite geometric series is only addable if your terms are getting smaller. And that means that your ratio must have an absolute value less than 1. This is linked directly to what we talked about yesterday in terms of limits. Remember what we talked about with our limits? We said if you are finding the limit of something like this, or if you're finding the limit of something like this, they're very different. Remember that conversation yesterday? What did we say about this guy? The limit would be 0. I heard somebody say it, thank the Lord. 0. Because what are those terms doing? Every time you multiply by 3/4, you make it smaller. What are these guys doing? They're getting bigger. When you multiply by 4/3, that's like 133%. You're making it bigger and bigger and bigger. So we call this one divergent. You can only sum them. These go on forever and ever. You can only sum them if they're getting smaller. So as long as your ratio has an absolute value less than 1, you can add. Otherwise you can't. You can't. Even though you have a formula, it won't work unless the ratio is less than 1. Okay? All right, let me see what's next. We're gonna do one problem backwards. Come on, give me a break. I only have a little more time with you. I need to take advantage of every minute. Besides, you paid for it or your parents paid for it. All right. I'm gonna write this in sigma notation. This right here is going to be the explicit formula for this series. Well, we talked about that earlier this period. What is going on in this problem? What kind of a sequence do I have?
Oh, arithmetic.
Arithmetic. With a common difference of 6. My arithmetic formula is this. For this particular problem, the nth term is -7 plus 6 times n minus 1. Would you agree with that?
Yeah.
So let's multiply that out and collect like terms. Did you get 6n minus 13? Or -13 plus 6n? Now, would you notice something? What happens if I put a 1 in here? If I put a 1 in here, what do I get? -7. What if I put a 2 in there, what do I get? -1. Or put a 3 in here, I get 5, and so on. So there is everything I need except, how do I figure out where I stop?
53.
Well, I don't put a 53 up there. The number that goes up there has to plug in to give me 53, right? So 6n minus 13 has to be 53. So 6n has to be 66, so this number must be 11. And there's your sigma. All right, we'll pause there. I think we're only gonna have one more day of note taking probably. Then we'll have to call it quits.